and get started now with my introduction. So thank you all for joining. Welcome to tonight's Terra Talk, or this morning's Terra Talk if you're joining from India or Southeast Asia and it's Thursday morning for you. I am delighted to introduce our guest speaker for today, Dr. Chip Fletcher, who is joining us from Hawaii. And before I give sort of more about Chip's bio, I'll just say that Chip is a dear friend of the Terra community who has been giving guest talks with us since our very first cohort back in May 2020. And we had such a good time at that talk, even though we were dealing with very complicated and disturbing topics of the realities of climate science and climate change, he came back and joined us for a second talk on sea level rise, which is another of his areas of expertise. And he's given a talk in every LFA cohort since, and even some of our new courses. So it is just a pleasure to welcome you here tonight. And to get into the bio, Chip Fletcher is the Associate Dean for Academic Affairs and Professor in the Department of Earth Sciences at the School of Ocean and Earth Science and Technology at the University of Hawaii at Manoa. And he's also a commissioner on the Honolulu Climate Change Commission. Chip teaches graduate and undergrad courses, and it continues to be an excellent, outstanding climate communicator about his research and sort of the gravity of the situation that we're facing, as well as the opportunities that we have to swiftly mitigate climate change. So this is just a great session that we're in for here. And I encourage everyone here to come back to this recording as much as you need, and I will be sharing it for everyone who's not here shortly after the talk concludes. So over to you, Chip.
Thanks, Lainey. Thanks very much. And thanks everybody for coming to spend some time with us. So are you, Lainey, are you looking at the one slide or the two slide?
One slide.
One slide, good, okay. So I titled this Human Security at Risk, Climate Change, Biodiversity Loss, and the Era of Pandemics, because our mismanagement of the planet has grown beyond simple climate change into other emergency status issues. So with regard to climate change, you are all mostly aware of sort of the fundamental issues that arise with climate change. We have sea level rise, we have extreme weather disasters, there is the development of heat beyond human tolerance. These lead to food and water insecurity, which in turn displace human communities and can lead to extreme cases of social inequity and injustice. And you may be familiar with the United Nations Framework Convention on Climate Change, Paris Accord or Paris Treaty from 2015. There, the world's nations agreed or pledged to cut their greenhouse gas emissions sufficient to stop warming at 2 degrees Celsius above the pre-industrial level, and to make strong efforts to stop the warming before hitting 1.5 degrees C. And in the intervening few years since the Paris Agreement, the climate change community, the global energy community, and the political community around the world has really come together to realize that stopping warming at 1.5 degrees is imperative, because it's just far too dangerous a planet to leave to our children should we allow it to warm up beyond 1.5 degrees. And as of just a month ago, the latest calculation is that we have 6 to 11 years of emissions left, greenhouse gas emissions left, before we break through this 1.5 degrees C target at the 67% probability, or 2/3 probability. Maybe everybody should mute their microphones. Thank you. But then on top of climate change, we also have a biodiversity problem. Since 1970, the human population has doubled. The per person consumption has increased almost 60%. that means that each of us needs 60% more stuff to get through the day than was needed in 1970. And GDP has grown by 400% in this 50-year period. Much of this growth has come at the expense of the natural world. Humans have altered 70% of the world's lands, 40% of forests have been eliminated. More than 1/3 of Earth's land surface is used for cropping or animal husbandry, food production. The global biomass of wild mammals is less than 25% of what it was 10,000 years ago. And the abundance of native species in terrestrial biomes has fallen by 1/5. 1.3 species on average go extinct every year, and this is 15 times the rate of extinction before the 16th century. 1/5 or 20% of Earth's surface is at risk of plant and animal invasions. Invasive species impact native species, ecosystem functions, and nature's contributions to people. These climate change and biodiversity loss have also magnified the era of pathogenic disease that we have entered. Over 270 human pathogenic diseases have been aggravated by climatic hazards. This is 58% of all documented diseases throughout human history. Climatic hazards bring pathogens such as what cause dengue, Lyme, and Zika closer to people because the range of vectors is expanding as warming expands climate zones. And likewise, people are in turn displaced by climatic hazards such as heat waves, storms, and floods, and come in closer contact to pathogens for that reason. Many pathogens are strengthened by climatic hazards. We see increased virulence in hot conditions. There's an increased season length, which can lead to increased breeding, and the areas that are available for breeding and growing of pathogens have increased as well with climate change. And likewise, humans experience a decrease in our immune systems. This is especially the case where climate hazards have led to malnutrition, heat disease, weakened immunity overall. And habitat loss, largely through food production, and concentrated animal feeding operations or animal factories increase human exposure to and the breeding of zoonotic disease. So we're going to go through all these topics. This is a very content-rich 45 minutes, and I expect to leave some time afterwards for questions. So let's begin with what's the latest that we know about global warming. The data has come in on warming last year. 2020 tied 2016 as now the two warmest years on the instrumental record. Warming has now reached 1.3 degrees C above the natural background temperature. And we've had a very linear rise of global warming since 1970, a rise of almost 0.2 degrees Celsius per decade. However, notice that the last 6 years have lifted off of this trend. And this indicates that we're looking at an acceleration of the rate of warming. Fundamentally, what's driving the situation is an anthropogenically enhanced greenhouse effect. The greenhouse effect works where sunlight comes in to Earth's atmosphere. Should sunlight encounter a bright surface, such as snow or ice cover, it is reflected back out to space. Should it encounter a dark surface, such as a water surface, the ocean, or even the land surface, it will warm up that surface, and that surface will then re-radiate energy in the form of infrared energy, which is a different frequency than the energy that came in directly from sunlight. This heat, this infrared energy, can be trapped by a group of gases in the atmosphere that occur in very small abundances, but are extremely powerful. Principally among these is carbon dioxide. We focus largely on carbon dioxide because it has a very long residence time in the atmosphere. We can have carbon dioxide that was emitted from your internal combustion automobile today, still in the atmosphere 1,000 years from now. The other greenhouse gases that we are seriously concerned about include methane, nitrous oxide, and a group of human-made molecules known as the fluorocarbons. These gases, the molecules of these gases in the atmosphere, will warm up themselves when they encounter infrared radiation, and they will re-radiate that heat back down to Earth's surface, heating it for a second time. At a natural level, this is extremely important because if we didn't have a natural greenhouse effect, the average temperature on Earth's surface would be below freezing. But just like having too many blankets on your bed at night can lead to conditions that are uncomfortably hot, too much greenhouse gas in the atmosphere leads to dangerous levels of warming. One of the important mechanisms that occurs when you warm the atmosphere is that you actually increase the most powerful greenhouse gas, which is water vapor. This is called an amplifying feedback. By warming the air with one of the fossil fuel generated greenhouse gases or the fluorocarbon greenhouse gases, that warmer air holds more moisture. You're all familiar with the fact that warmer air is more humid. Well, it's that humidity, that water vapor, that is actually the most powerful greenhouse gas. And so for every 1 degree of warming that we get from the initial greenhouse gases that we release, we get an additional degree of warming from the increase in water vapor that results. This is called an amplifying feedback effect, and we see this process of amplifying feedbacks throughout Earth's climate system. Carbon dioxide has grown consistently in Earth's atmosphere for several centuries. We began monitoring it in the late 1950s. The rate of increase at that time was less than 1 parts per million per year. However, now we see CO2 increasing in the atmosphere at over 2.5 parts per million per year. There's been no slowdown, and the rate of this greenhouse gas accumulation in the atmosphere is accelerating. Again, CO2, methane are generated by the combustion of fossil fuels, including coal, oil, and gas. And here you see the history of energy consumption from over a century. And you can see that fossil fuels in general, coal, oil, and natural gas, constitute almost 85% of the energy consumption in 2019. This is global energy consumption. Nuclear produced about 4.5% of the consumed energy, and combined hydro, wind, geothermal, biomass, and solar energy produced about 11% of the energy consumed on the planet in 2019. We release about 86% of carbon dioxide through combustion of fossil fuels and other industrial related or transportation related fuel consumption, and another 14% through land use practices, which include various types of agriculture, and from many types of agriculture, especially in tropical biodiverse countries, there's a great deal of deforestation that takes place. Once released, about 46% of the CO2 that we produce goes into the atmosphere. About 30 or 31% is taken up by the terrestrial biome and the marine biome, that is through photosynthesis. And another 23% dissolves in the ocean, producing ocean acidification. The combination of water and carbon dioxide produces H2CO3, which is a type of an acid. And so this leads to ocean acidification and interferes with the secretion of the exoskeletons, the shells associated with coral reefs, as well as the bony skeletal material of finfishes, and also much of the world's plankton secretes a mineral compound known as calcium carbonate, CaCO3, which reacts with H2CO3, the carbonic acid which is produced. However, we are now learning that we are coming dangerously close to losing that 31% storage of carbon dioxide in the terrestrial biosphere. Photosynthesis pulls carbon out of the atmosphere, but the other part of plant metabolism is called respiration, and that releases carbon dioxide into the atmosphere. Both photosynthesis and respiration are temperature dependent. And we've already in the past decade, the warmest 3-month period of the past decade, passed the thermal maximum for photosynthesis, right? Photosynthesis is temperature dependent. And there comes a point where as you increase the temperature, photosynthesis becomes less efficient and you see a decrease in photosynthesis, but an increase in respiration. At higher temperatures, respiration rates rise exponentially while photosynthesis rates decline exponentially. This decoupling cuts the ability of the terrestrial biosphere to store carbon. And in only 2 decades from now, it's expected that this ability will be cut in half, so that we'll go from 30% of our carbon release to only 15% of our carbon release being stored through photosynthesis. As part of the Paris Agreement, the pledges, which are known as intended nationally determined contributions that came from every nation, over 190 nations, they rely heavily on the land's ability to pull carbon out of the atmosphere, which we see here is on the verge of decreasing dramatically, almost being cut in half. And as terrestrial carbon storage degrades, national pledges to the Paris Agreement grow increasingly irrelevant. We are approaching, in fact, a tipping point where the global land surface will switch from a carbon sink to a carbon source. And this positive feedback then implies that global warming would continue without any further contributions of greenhouse gases from ourselves. And a paper came out last week, which was quite startling. It studied the Amazon rainforest basin. It found that the Amazon in general is threatened by warming, air temperature warming, wildfire, farming, reservoir construction of the many rivers that are there, drought, hunting, overfishing, and mining and oil extraction. Amazonian trees alone emit 3.5% of all global methane. This has been the case for a while. Reservoirs that we create by damming the rivers in the Amazon also release methane. And the wildfires that take place both through farming and through deforestation release black carbon particles into the atmosphere, which warm up with sunlight and then re-radiate that warmth as infrared radiation. In other words, an additional component of infrared radiation, which is trapped by greenhouse gases. Soils, as they warm, also release nitrous oxide. When you combine all these, the warming from methane and black carbon release likely offsets and probably exceeds the climate service provided by atmospheric CO2 uptake. So we're looking at a situation now where it's likely that the Amazon is already a net source of greenhouse gas emissions. The Paris Agreement, again, signed in 2015, adopted by 196 parties. The goal is to limit global warming to well below 2 degrees Celsius, preferably to 1.5. Every 5 years, the agreement requires that every nation announce new and more ambitious action related to reducing their greenhouse gas emissions. And the first 5-year period ended in December last year, 3 months ago, December 2020. And the updated ambitions by the signatories to the Paris Agreement only came in from 75 nations, representing 30% of global greenhouse gas emissions. The rest of the signatories to the agreement did not submit new pledges. And less than 1% reductions by the end of this decade are what are pledged by these 75 parties. Now, the Intergovernmental Panel on Climate Change, which is a group of volunteer scientists that come together every several years and produce reports on the problem of climate change, produced a report specifically on the 1.5 degrees C goal in 2019. And in there, they said that greenhouse gas reductions need to be 45% in 2030 compared to 2010. Note the bullet directly above that the pledges so far constitute less than 1% reductions by 2030. 64 countries cut their fossil fuel emissions during the 3-year period prior to the pandemic. The total cut was a reduction of 0.16 billion tons of carbon dioxide per year. This is only 10% of the reductions in carbon dioxide emissions that are needed. What is needed is 1 to 2 billion tons of carbon dioxide cut per year in order to stop warming at 1.5 degrees C. Emissions decreased in these 64 countries, but they increased in another 150 countries over that 3-year period. And globally, emissions grew actually 0.2 of a billion carbon dioxide tons per year over that 3-year period. So the truth is that fossil fuel use is accelerating faster than renewable fuel use. And what you see here at the end of this history begins in about 1965. You see the fossil fuels growing faster than the renewable fuels down below. And this faster growth is similar to what happened when oil was discovered in the 19th century. The discovery of oil did not replace coal. It simply helped coal. It added to coal's ability to meet the demand for new energy. And that's what's taking place, unfortunately, with renewable forms of energy. They are meeting the demand for new forms of energy, not replacing fossil fuel as a form of energy. In fact, we just learned that the carbon dioxide emissions at the end of last year, in December of 2020, were already 2% higher than the emissions in December of 2019. So the end of last year already is showing us a recovery and an acceleration of greenhouse gas emissions compared to prior to the pandemic. So that overall, what you see here is various pathways of gigatons of carbon dioxide, billions of tons of carbon dioxide released to the end of the century, to 2100. And the current pathway that we are on is shown by the dashed red line. We are not in a worst case scenario, and this is important, but we are still in a scenario which will lead to warming above 3 degrees C, which is an extremely dangerous level of warming. So what are the impacts of climate change? We see Greenland melting has quadrupled since 2010, and Greenland is now irreversibly melting. If we were to stop global warming today, Greenland would continue to melt for many, many centuries, eventually melting down. The melting of Greenland is today contributing about 26% to global sea level rise. Antarctica is also in a state of net ice loss. There are some areas in Antarctica showed in blue where there's still more snowfall than there is melting, but overall, the entire ice sheet is in a state of loss, and it contributes about 14% to today's rise of global sea level. And in this area shown in the dark red, we have a set of glaciers that are already irreversibly retreating. This area is known as West Antarctica. From this area, we have glaciers that flow into the ocean, and their leading edge will float on the salt water. This is called a floating ice shelf, and it actually helps to buffer the continued flow of ice off the land. But these ice shelves are melting dramatically from underneath because there is warm water that is very salty that is causing these ice shelves to decay on their underside, as well as the warm air is causing them to melt on their upper side. And there's so much ice on the landward side there that it's pushed the continent down below sea level. So the glaciers enter the ocean from valleys that are below sea level. This is called a retrograde valley. And so the only thing keeping these glaciers from flowing extremely rapidly now is the ice shelves that are grounded on the shallow seafloor underneath. And as these ice shelves continue to melt, there is a real fear that they will lift off the seafloor, no longer be grounded, and flow extremely rapidly into the ocean. And two of the largest glaciers are the Pine Island Glacier and the Thwaites Glacier. And you can see these short videos of them flowing. This paper came out in 2020, last year. And the research team concluded that the natural buffer system that prevents Pine Island and Thwaites glaciers from flowing rapidly is breaking down. That's the floating ice shelves. The ice shelves are showing new damage areas that are the first signs of structural weakening and precondition these ice shelves for disintegration. And now with this finding, we really have to confront the possibility of multi-meter sea level rise this century. Sea level is rising today at about 1 foot per century, or 3.4 millimeters per year. We've been measuring sea level with a set of satellite missions that use what's known as satellite altimetry. That's the emission of microwave beams that reflect off the ocean surface back up to the satellite. The two-way travel time is a function of distance. And we've been measuring the world's ocean surface since 1993. Since that entire period, the rate of rise has begun to accelerate. And over just the last 10 years of measurements, we see a 50% increase in the rate of rise to 4.6 millimeters per year, or 1.5 feet per century. Our climate models are projecting that by the end of this century, we're looking at between 3 to 5 feet of global sea level rise. And that would be the case if we do not see rapid disintegration of floating ice shelves. However, as we now know, there is evidence that rapid disintegration may be taking place. So this 3 to 5 feet is considered a low estimate by many scientists. However, sea level rise is not going to stop at the end of this century, and the projections are that we'll see 10 to 16 feet of sea level rise 2 centuries out. At 2 degrees Celsius, the warming target of the Paris Agreement, sea level will rise ultimately 25 meters or close to 80 feet over the course of the next 30 years. That is because the ocean surface requires that much time to expand as it warms, as it equilibrates with the temperature of the atmosphere. The ocean surface will warm as it absorbs heat from the atmosphere, and that will cause thermal expansion of the ocean. We'll also see melting of Greenland and Antarctica and the world's mountain glaciers taking place over the course of that 1,000 years. So this is one of several reasons why stopping warming at 2 degrees C is actually a very poor target, a very unsafe target. As we warm the air, we accelerate the water cycle. And we are now seeing global weather disasters that have tripled in 2 decades. Here is the history in the United States of individual weather disasters that caused more than $1 billion of damage. And you can see that we are increasing the billion-dollar disasters very dramatically. This past year, 2020, had 22 individual weather disasters that caused over $1 billion of damage. That is a record. The previous record was 16 individual events. And we saw $95 billion in damage in 2020 and a total of almost $2 trillion in damage due to weather disasters since 1980. This is beginning to bankrupt us, not only the federal budget, but state, county, municipal, and all levels of budgets are required in the recovery phase and the rebuilding phase after a weather disaster has hit. So if this continues to increase, we're going to enter a world that is fundamentally uninsurable and that drains public budgets simply to recover from increasing amounts of weather disasters. Global extreme rainfall has increased 12%. 70% of the world population and GDP now face a 500% increase in flood impact. The Western United States fire season is 150 days longer than it was 4 decades ago, and the number of large fires has tripled. And the conclusion of this paper, published in the Proceedings of the National Academy of Sciences, has me personally very worried. We are on a pathway that by 2070, we're looking at almost 1/5 of the land surface on the planet being too hot for human existence. Today, we have about 0.8% of the land surface too hot for human existence. And that's these black areas in the deep Sahara and along the Red Sea coastline. But as we continue along a pathway to 3 degrees Celsius, that is going to expand to almost 1/5 of the land surface, 19%, too hot for human existence. And we're looking at basically all of Southeast Asia, Northern Australia, India, the Middle East, North Africa, and large parts of the Americas. Everything that is in the dark brown with the diagonal hatching is a model result that has statistical significance. Obviously, this is a recipe for human displacement, and how that will play out in terms of food and water security and political chaos is quite alarming. And we are in a freshwater crisis. We are withdrawing 17% more fresh water from aquifer systems on the continental United States than nature can replenish naturally. China withdraws 22%, India 52%, and in the Middle East and North Africa, they are pulling thousands of percent more water out of aquifers than nature can regenerate. And by 2050, water demand is projected to grow by 55%. Already today, 1/4 of humanity faces a looming water crisis every year. 17 nations are under extremely high water stress, meaning that they're using almost all the water they have. As we raise the amount of CO2 in the air, soy, corn, wheat, and rice become less nutritious. We see up to 13% decrease in protein, zinc, vitamin B complex, and iron. As an example, we can look at global wheat. Wheat currently provides 1/5 of all human protein, but the yield every year is threatened by drought, flood, fire, and also the higher CO2 in the atmosphere. By 2050, the demand for wheat is projected to increase 60%, but the yield is projected to decline by 15%. By mid-century, an additional 300 million people are projected to be now malnourished from this effect, and an additional 1.4 billion women and children likely to have iron deficiency. Food and water shortages can lead to conflict. And the Center for Climate and Security, which is a think tank for the US military, concluded that even at scenarios of low warming, each region of the world will face severe risks to national and global security in the next 3 decades. Higher levels of warming will pose catastrophic and likely irreversible global security risks over the course of the 21st century. An example of what we're talking about has taken place in the nation of Syria. Syria experienced the worst drought in 1,000 years 2 decades ago. That led to a collapse of its farming economy and an influx of farming families into Damascus, Homs, and other urban areas where the corrupt government of President Bashar al-Assad led to a rebellion. A civil war developed because there was very little in the way of government services provided for schooling, medical, employment, food and water. And the young men formed a rebel force and civil war broke out. At the same time, the US and coalition forces were pushing Al-Qaeda out of Afghanistan and Iraq, and they found safe haven in Syria. The result of this chaos was the very violent development of ISIS. That pushed people, 4 million individuals out of Syria, and they moved towards the European Union, either along a northern route through Turkey across the Aegean Sea or a southern route where they entered Libya and Tunisia and attempted to cross the Mediterranean. There were amazing and extremely sad human tragedies as smugglers loaded these refugees into unseaworthy boats. And we had an influx of millions of immigrants into Europe. The result was that in some locations, there was a backlash by local communities. This didn't happen everywhere, but the backlash was profound enough that it led to the rise of political figures of extreme authoritarian types of political platforms. We saw the rise of nationalism, populism, tribalism, the turning inward of communities and political parties as a reaction to the influx of the immigrants coming out of Syria and North Africa. Few of these politicians were elected. However, one was, Sebastian Kurz, was elected on a campaign of tougher immigration controls, quickly deporting asylum seekers, and outlawing membership in certain Islamist organizations. All right, let's watch a short 2-minute video on, it's a trailer actually to a movie called Age of Consequences, which speaks to this issue from the US military point of view.
We built society on this assumption of climate stability, and that stability is changing. All these things we take for granted, they're not just givens anymore.
The just released report from the Pentagon, climate change and the challenges it's creating for the military. The latest report says global warming is driving weather to new levels of extremes.
99% of my intelligence told me there's an ambush waiting for me. Yes, yeah, but there's that 1% that says there's no ambush. So the hell with the other 99%.
As a member of the United States military and 30 plus years of service in uniform, climate change is what we call an accelerant to instability.
If you have an area that is already unstable and then has the additional challenge of water shortages or food shortages or a disaster that makes people move, then you can start seeing conflict situations.
Syria's deadly conflict, a full-blown civil war.
If we look around the world today, we can already see conflict and climate in play right under the headlines that we're reading.
The new study finds climate change exacerbated the worst drought ever in modern Syria as a consequence of human interference.
Fragile social systems just need one more shock to tip them over the edge into social breakdown, into war.
Failure to think about how climate change might impact our globally interconnected system is a failure of imagination.
The flip side of the climate threat is the energy and resilience opportunity.
As a soldier, we're always looking to have an edge on the future. We can pay now, pay later.
This movie is a documentary that I believe you can download from Netflix. Climate change and overpopulation have also created a biodiversity crisis. The oceans are hotter, more acidic, and have 2% less dissolved oxygen compared to 1950. And projections are that the world's coral reefs will experience annual bleaching by mid-century. We now have global bleaching events typically associated with major El Niños. And for coral reefs that are located near human communities, the discharge of partially treated sewage into coastal waters leads to the rise of invasive algae. And the reefs may have been able to recover from bleaching, but when they are smothered by this invasive algae, it prevents the recovery of the reefs. And we see the destruction of the coral reef ecosystem associated with human communities. And in fact, we see a new phenomenon now called reef collapse. And that's because the coral themselves are no longer secreting the solid mineral material, the exoskeleton of the coral polyp. And bioeroders work through the coral reef and in very short order permeate the coral reef with large porosity, with tunnels, and the coral reef actually can collapse. This leads to a deepening of the seafloor near the coastline, which allows more wave energy in and can accelerate coastal erosion and can increase the amount of storm surge and tsunami run-up that occurs. Overall, the terrestrial biome is severely impacted by human pressure. 58% of Earth's land surface. In other words, everything shown in red here is considered impacted by human pressure. In only 20 years, we've lost an area of ecologically intact land the size of Mexico, and only 25% of terrestrial Earth can be considered wilderness. And this includes the permafrost areas and the desert areas. Since 1970, food crop production has increased 300%, and half of all agriculture expansion has come at the expense of forests. We've destroyed an area the size of Africa to grow animals for eating. We are deforesting the planet at the rate of 30 football fields per minute, largely to raise cattle and the grain to feed them. 43% of all ice and desert-free land, 2/3 of all freshwater use is for food production. Over 80% of farmland around the world is used for livestock, but it produces just 18% of food calories and 37% of protein. Cattle and the grain they eat use 1/3 of available land surface on this planet, 16% of all available fresh water, and 1/3 of worldwide grain production. Producing beef generates 100 times more greenhouse gas than plant-based food. And we have an industrial form of agriculture which relies on human-produced pesticides and nutrients, most of which runs off into the adjoining watershed, causing pollution. Plus, we plow up the soil. We plow up the soil and expose it to the air, where the carbon in the soil oxidizes and turns into CO2 that is released to the atmosphere. Lainey, was that you that spoke?
No, that wasn't me. I was just going to see if it was a question or a moment, so I'll get back to you, but please continue.
I'm gonna keep on moving forward. I want to get to the end here.
Yeah.
Now we're starting to see papers like this one, which is titled Pervasive Human-Driven Decline of Life on Earth, points to the need for transformative change. The world is increasingly managed to maximize the flow of material contributions from nature to keep up with rising demands for food, energy, timber, and more, with global trade increasing the geographic separation between supply and demand. This unparalleled appropriation of nature is causing the fabric of life, on which humanity depends, to fray and unravel. Of all mammals on Earth, 96% are livestock and humans, only 4% are wild. Of all birds, 70% are poultry. We've also entered into the era of pandemics. 70% of emerging diseases and almost all the known pandemics, such as the flu, HIV/AIDS, and COVID-19 most recently, are zoonoses. These are caused by microbes carried by animals that spill over to humans through contact with wildlife and livestock. The emergence of these zoonoses is driven by habitat loss, agriculture practices, and climate change. The climate change connection includes an expanded vector range. The animals and insects that carry these pathogenic microbes are now expanding into more areas. Extreme weather causes human displacement and weakens the human immunity system. The habitat loss through agricultural expansion and wildlife trade and deforestation brings humans and pathogens into contact. And we have concentrated animal feeding operations. These CAFO systems are a breeding ground for especially virulent pathogens. They generate 98% of the meat consumed in the United States. Normally in nature, a virus will evolve a more moderate virulence in order to keep from killing its host. But in conditions like this, the animals are densely packed and host-to-host transmission is easy, and there's less evolutionary pressure to reduce virulence. When an animal dies, its carcass is removed and a live animal is is brought in to replace it. So there's a link between intensive poultry production and the emergence of highly pathogenic forms of avian flu with a 60% mortality. Pork, poultry, and beef were kept alive by pumping them with antibiotics, and nearly 2/3 of drugs important to human medicine in the United States are sold for keeping animals like this alive. Overuse of these medicines has driven the rise and spread of bacterial resistance. And we can reduce pandemic risk by reducing meat consumption, reducing the consumption of wildlife and wildlife-derived products, and conserving high biodiversity regions. Papers with extraordinary titles are now being published by scientists who are trained to be discreet and unemotional. And yet the evidence that's being collected by teams of scientists is requiring that the truth be revealed and published. Sixth, mass extinction, biological annihilation, a terrestrial biodiversity boundary that we may be exceeding, approaching a state shift in Earth's biosphere, the loss of animals in the world's oceans, marine defaunation. And we've already seen this pervasive human-driven decline of life on Earth. This paper has a co-authorship of over 15,000 scientists. And it's a warning. It concludes that humans have pushed Earth's ecosystems to their breaking point and are well on the way to ruining the planet. And finally, what are the solutions here? The solutions need to break this relationship. We have atmospheric CO2 on the vertical axis, world productivity, economic productivity or GDP on the bottom axis. And we see this linear relationship since the end of World War II, since 1950. World productivity has increased in direct linear relationship to the release of carbon dioxide into the atmosphere. This needs to be broken. This needs to be replaced with non-fossil fuel forms of energy. And there are 6 emission sectors that need to be converted to renewable energy: the electricity sector, the food sector and land use sector, industrial production, especially cement and steel, transportation, buildings, and fugitive emissions or flaring of natural gas constitutes 10% of emissions. To achieve this, governments need to be the most responsible for taking action through new policies and programs and requirements. The commercial sector must embrace a low carbon marketplace, and every part of society, including individuals, must experience transformational change. Nobody can be excluded. How do we stop warming at 1.5 degrees C? By 2030, 9 years from now, global emissions must fall by 40%. We must have an agriculture revolution. In fact, the number of people who are malnourished and underfed and the number of people who are obese is roughly equal, both of them over 1 billion. We have a broken global food system, and we need to replace red and white meat consumption with artificial meat and plant-based meat, marine protein, and much more consumption of fruits, nuts, and plant-based and plants. And we need to produce food sustainably using crop rotation, cover crops, minimum tillage, and new perennial staple foods. Our transportation system has to have 50% of all cars globally by 2030 move to electric energy, and that electricity needs to be generated renewably. We need a zero emissions industry. Coal use must dive from supplying its current 30% of power down to 6% by 2030 and continue to decline. We need R&D, research and development on low carbon steel and cement. We need a zero emissions electric grid. 500 gigawatts of solar power capacity needs to be added annually around the world. And in 2019, we added 110 gigawatts. That needs to increase almost 5 times. We need to retrofit buildings. 1/3 to 1/2 of all buildings globally need to be retrofitted for renewable energy and efficiency by the end of this decade. So these are the details of decreasing our emissions by at least 40% by the end of this decade. That's the pathway to stopping warming at 1.5 degrees Celsius. And we need to enhance our sinks, natural soils, conservation practices in growing food. All of these will absorb carbon from the atmosphere and store it for the long term. We need to take advantage of blue carbon, which is the storage of carbon in the world's oceans, mangroves, algae, seagrasses, salt marshes. Forests are carbon dioxide sinks. When they are increasing in density or area, we must stop the deforestation problem immediately. And mechanical carbon capture and storage requires a huge amount of investment. And there are various ways of enhanced weathering and geological sequestration to aid or help with the natural carbon sinks. Regenerative farming looks like this. We need to stop this open soil farming and we need to use cover crops. And we need to stay informed. We need to think and speak and increase our level of information with regard to climate change. I get a daily email feed from Carbon Brief. I get another one from the Daily Climate and another one from Inside Climate News. These are available and they're very readable. And we need a collective political will to remove fossil fuel subsidies and incentivize renewable energy. We need to agree on the morally harmful nature of fossil fuels. We need to build carbon neutral cities, divest from fossil fuels, and strengthen climate education and engagement, and include carbon footprints on purchases and price the true cost of carbon. I'm going to end with that. Too many people ask me, do you have hope? The answer is, hope is not a strategy. What we need is courage of each and every one of us to step up to the plate and be messengers about climate change, biodiversity loss, and the need to rescue this planet. Thank you very much. I'll end with that.
Thanks so much, Chip. That was, as usual, a phenomenal and sobering grand tour. And I love that you ended with that slide about the social tipping points, because we're going to explore more of the environmental tipping points in the next class to be released. But I think these social tipping points are also really important to keep in mind as you concluded. There's been a ton of great questions coming in from the chat, and I'm just going to scroll back and call up some of them that were really seconded. And if I miss yours, feel free to type it again and keep typing them in, and we'll just do the best we can. And I'll just send you any lingering ones after it's really time to wrap up, Chip, so we can follow through in email form.
Stay late. I'm sorry I went so long. I haven't left any time, but I can stay on.
No problem. Okay, great. Thank you. One question that got a lot of seconds was, how do you stay focused and relatively positive and realistic in light of this data that you live and breathe each day? So let's start there.
It hasn't been easy. There's actually an official psychosis called environmental grief or ecological grief. It was published in Nature magazine. And ecological grief is hypothesized to hit scientists first, because they're the first ones to invest in the learning of these things. But I'm depressed. I'm very upset. I smile a lot because it's just part of my nature, and I crack jokes all the time, and that's what keeps me functional. But I track emissions in detail, and I track projected emissions. And thank goodness we've changed the administration in Washington, D.C., and thank goodness they have as one of their 4 pillars, climate change. And one of the other pillars is repairing social inequity and injustice, and that they are moving out into the world once again and being emissaries, providing leadership and bringing other nations along. Thank goodness that is taking place. And there is a ray of optimism associated with that.
Yeah, absolutely. And so we had another question, which I also really appreciated, that if we had not 45 minutes, but 45 seconds, what's the best factual elevator pitch to get someone to hone in and read more about all of this? Is it land ice melting? Is it the ocean conveyor belt stopping? X more fires? Like, what's your what's your take?
Do you love your children more than you love yourselves? Stop polluting the planet.
Nice. Less than 45 seconds. That was really good.
That's 1 floor on an elevator.
Nice. So, okay. And then one that came in at the very beginning was about how you deal with climate denial. And
I don't engage it.
Yeah.
You can't change another adult's mind. You have to lead them, and they have to change their own mind, right? You can't tell a smoker to quit smoking. It's up to the individual. And so I'm happy to have discussions, but I will not go into arguments. And the moment someone starts to push back on something that I know has been published and is legitimate science, I'll just say, well, I guess we have to disagree on that point, and move on to something else. So it's not my job to change people's minds. It's my job to present the evidence to them.
Yeah, absolutely. Yeah, I've heard that from other climate communications resources as well, that at least in the United States, it is such a smaller fraction of climate skeptics and denialists that it's better to focus on catalyzing action in those wanting to do something, but not knowing exactly what or how. So that's, yeah, another interesting consideration. Yeah. It is frustrating though.
5 to 10 years ago, it was a real issue. I mean, at all my public talks, there'd be a crowd of people who just wanted to argue, but I don't encounter it very much anymore.
Yeah, interesting. Yeah. Okay, so I also had a question that someone seconded, so I feel like it's not just coming from me. So I feel happy to share. So I've read recently about deploying solar on massive scales, like solar farms in the desert, that it might have such a strong impact on the albedo from the black surfaces that it actually leads to localized warming, that, and more than localized, like regional warming. So does this mean that we should be more carefully deploying solar, even as it grows as a clean energy source, in more like distributed settings or not on massive farms, even though that's like kind of cheaper per watt?
Well, I mean, this is true, and this is part of the technology that goes into converting our energy sources. So there are solutions to the reduced albedo associated with deploying solar or wind, wind turbines for that matter. The truth is that as we increased forests from barren grasslands to forested lands, that's actually a darker surface, which is a decreased albedo. So the details here are very important, and that's where government policies can come to play. Specifically, in the case of solar, large deployed community scale solar, making sure that this problem, doesn't occur. That's where government policies can provide that sort of guidance.
Yeah, absolutely. I was thinking that too, when I was like, it's not just cost per watt that's like the only number or statistic that matters when we're deploying clean energy. Like co-benefits on the local ecosystem or avoiding unintended, negative climate impacts is another, of course, important thing to think about. So that was just eye-opening for me to read. Yes, I will share the source where I read that for sure. Let's see, are there any other questions coming in? I see one from Rishi. Are there specific policies that are either in the works or that need to be drafted that we should be calling our senators about? I can think of some, but I'm not sure what will make the most impact fastest. And Rishi, if you just want to unmute, and are you coming from the US? Is that you're in?
Yeah, I'm in
US,
San
right?
Francisco.
Yeah. Oh yeah, that's right. Okay, just clarifying.
Well, I mean, all the economists that have studied the problem of climate change point to the need for a carbon tax, right? This is Arthur Pigo was a Cambridge economist in the 19th century who said, we need to make it cost more for activities that cause costs to society. And cigarettes are a great example. Cigarettes have a Pigovian tax because so many people were smoking that it raised the cost of healthcare, and the rest of us who did not smoke were paying for the healthcare for those who did smoke. So, but apparently the Biden administration has rejected the idea of a carbon tax, and so something like that now probably the focus should be at the state level or the local community level. And I would add, I think that a carbon tax is a great way to implement some social equity. The fee and dividend style of a carbon tax is that you tax purchases based on the carbon footprint that they have. Then that is delivered back to the consumers in the form of a check every month or every year, but put a salary cap on that check. People making more than $100,000 a year don't get that fee back or the dividend back. And instead, it's concentrated at folks who are at the lower income earning level. This could be a very powerful way to pull people out of poverty, pull communities up. And in fact, those folks at the higher salary levels will benefit from that as well. So I actually think a carbon tax and a fee and dividend version of that could be very powerful.
Yeah, awesome. I agree. Great question as well. We have a few more really good ones. So Pavan was asking about the reduction of nutritional value in crops due to elevated CO2 levels. And that means that we require more food to get the minimum nutrition required, which I'll just add, in the United States, we are over nutrient nourished. We just like pee out the excess nutrients that we consume. But in other places, that's certainly not the case. But is there some way we can counter this decrease in nutritional value in crops due to increased CO2, which is certainly a real concern?
With regard to wastage, is it 25% of all food or half of all food produced is wasted, never actually consumed? From the farm all the way to the retail level, there's food being thrown away constantly. What happens is that the plant, when it reaches a certain amount of CO2 in the air, yes, CO2 is plant food, but the plant starts putting energy into the stalk and the leaves and not into the seed or into the food part of those four cereals: corn, wheat, rice, and soy. And so the big thing is that protein actually declines and it's replaced with carbohydrates. So plants actually become more sugary, more junk food with increased CO2 in the air. So I'm excited by what I hear with regard to plant-based meats. Apparently, they are growing portions of cattle and swine with plants that taste like parts of those animals. Now, I've been vegetarian for too long to really care about that taste anymore. It's not part of my diet, but for people who love the taste of meat, this is such a wonderful solution for them that they continue to have that option.
Yeah, agreed. My personal food commitment is going to try and eat more kelp this year. That's my desired source of new protein and iron and vitamin K, all these things I've been reading about. Yes. Okay. So a few, we'll just do maybe 2 more questions and then I'll wrap up because I know it's getting late for some folks and I'm also getting hungry. So one question is about the thoughts on the state of ESG investing. Someone was on a session there on Clubhouse about this topic. And so we've talked about policy a little bit. So the state of ESG investing, I guess, what can companies in the private sector do to do more than they have in the past?
You know, I'm not embedded in that sector, but I continue to see headlines and articles. Is it Larry Fink, who's head of BlackRock? I'm probably getting something wrong there, but a year ago, he called for the end of investment in coal. It turns out he didn't really adhere to that very strongly, but I understand that he's starting to strengthen his position. And there's also the United Nations sponsored, there's an organization that has several $1 trillion of equity that has 10 principles of responsible investment. In fact, responsible investment is the title of the office or program or whatever it is. They have offices in Paris and London. I'm not sure about where they are in the United States, but they offer sort of an umbrella opportunity for ESG investors to follow guidelines that are consistent with the Sustainable Development Goals that the United Nations is promulgating. So there's a lot of guidance out there for investors and lots of opportunities growing all the time.
Yeah, absolutely. And we have recently launched a course for venture capitalists in Ontario, which Chip has also spoken to. So yeah, we're working all the angles here. So I think I'm going to cut it off here and just kind of thank everyone. A few folks have had to drop off and added many thanks. And there's just one question which we're gonna get to in the next class. So I was just gonna comment that over to that person. But you guys are bringing up excellent questions and great points. And one person asked if there's a way to get in touch with you, Chip, after this talk, if they feel a burning need for more climate science answers. So is it okay if I share your email address with the fellows, or I can be an intermediary?
Yep. You can share my email address.
Okay.
Also, you know, if I depressed you today, I'm sorry, but what I've hopefully have done, and actually what I hope I did, was put you into one of the stages of grief, right? There are these stages of grief, you have to work your way through them. There's denial, there's negotiation, like, oh my God, this can't really be true, can it? But you come out the other side with acceptance. And once you accept this, once you realize that the scientists are not fibbing to you and we aren't lining our pockets with climate change grant money, once you accept that this is real, then you can do something about it and feel really, really good about yourself and your life. And I encourage all of you to embrace your grief. Do something positive with it.
Yes, you totally anticipated me. I was gonna say, and Chip, like, what are your final words for us here as we, keep moving forward and getting up out of bed every day? And yeah, that's just such a great point, and I can't underemphasize. I mean, just seeing you all here is one of the things that makes me feel more courageous in my life, and the fact that people are taking the time to face the sobering information and be more empowered to thus communicate and act on it. And we have learned from Chip's talk and a lot of the reactions that come up from it that it's good to process these emotions. And we have Carolyn Hickman from the Climate Psychology Alliance to lead 2 sessions for us later this week. So I encourage folks to come to that. It's another empowering perspective and field of study that is amazingly relevant to this work we're all doing. So thank you so much, Chip. And it's always a pleasure. I mean, in a weird way, but it is. And everyone else, take care, and I'll see you later this week.
Bye, everybody. Thank you very much. Bye-bye.
Thank you so much.
Thank you.
Yes. Thank you.